Let's jump into, I guess, a basic just cluster architecture. So this is kind of the architecture that we're working with in our HPC lab. How I've set up this environment is we have a head node that's connected to some external network that I'm going to be SSHing into. This head node is connected to an internal cluster network, which Warewulf will be doing provisioning on, and the various Slurm services are also running on this internal cluster network. Not in this environment, but this is very typical with on-prem environments, as you'd also have an IPMI network. What this is meant to do is this enables you to control your compute nodes from your head node and be able to power them on and off without actually going into your data center and hitting a button, which makes it really convenient. And I've, if you're a sysadmin, you know the feeling of having to go into the data center and actually hit a button is very annoying. And, if this is a way to prevent you from having to do that. And then lastly, as part of this environment, we just have a compute node that is running slurmd. This is basically the Slurm client, which will talk to the controller to either basically accept work and communicate with the controller. And there's one more service that I have on here that I didn't mention. Slurm DVD is basically the Slurm database daemon. This database daemon is basically responsible for writing job accounting data to a MySQL or MariaDB database. And it also can store job completion data as well. So you would want to run this in your environment if you want to do some reporting on the usage of your cluster, stuff like that. And by being able to generate these reports, you can take these reports, show them to your management, and show them the value that your equipment is actually delivering for your organization.
So real quick, Brian, I know the title of this is Rocky, Apptainer, Warewulf. I know we have stuff up here about Slurm. Do you want to give just a real quick, I know you talked about from a reporting perspective, you want to just kind of real quick, high level, what is Slurm?
So Slurm is basically a workflow scheduler. So basically it offers an interface for users to submit workflows either in batch mode or interactively, and have these workflows run on your compute cluster. And basically Slurm has like a lot of features where you could optimize Slurm configuration for your workflows, whether it's from setting resource limits, implementing access policies, all that type of stuff can be implemented in Slurm and also tracked as well. On this bottom prompt, I basically just set up a test user, and within this cluster, I have Slurm running. So if I do an sinfo here, you can see I have one node up, HPC Lab Compute 0. As a user on a cluster, something I would try to do is set up a interactive job which lands me onto a compute node so that I could try, maybe building my software and testing it out on some of my data. And this is just for testing purposes before I start launching a bunch of workflows into the cluster. And I just want to make sure my stuff works and that my software is working. So the typical workflow that I would do is I would start off with a interactive job. And this should put me on compute node 0. And right now I am going to try to do, and if we take a look in my home directory, I basically have this Warewulf Rocky Linux 8 container that I'm just going to try to shell into with fake root. So shell and add a fake root here. Or first, we can start with just showing into it normally. If we do who am I, you can see that I'm the same user. So if I exit out of this and I try to use fake root, it gives me a warning that I basically don't have a user mapping for this user in /etc sub UID basically. And the purpose of this demo is to show you how to get these files basically onto your compute nodes through Warewulf. And because I don't have this user mapping, I don't have the basically in the fake root context that I'm in right now. It doesn't have the full capability of Apptainer's rootless, I guess, feature basically. So let's back out of this. I'm just going to exit, and let's get out of this interactive job, and let's see how I'm actually going to implement this. So taking a look into Warewulf now, I basically have this overlay set up called Apptainer fake root. And within this overlay, I basically have /etc sub-UID and sub-GID with this .ww suffix on it. And you might be wondering, what is this suffix on this file? The suffix basically denotes that this file is a Warewulf template. So let's actually take a look at what this template actually is. So if I cat this file, and let's just take a look at some. And basically catting this file within this overlay, you can see that I have this line which includes the file on this specific file on my controller node. And if we take a look at that actual file on my controller node, we can see that we have a mapping for test user that's already here. So by having this file on my compute node, I should be able to use the full featured fake root feature. So to do that, let's first so I also want to show you the node that I am, the compute node within Warewulf as well. So as you can see here, what I would like to point out in this line here is the runtime overlays are coming from this default node profile, which currently just contains the generic overlay, which contains things like your users, your groups, and all that type of stuff. So how do we actually get this overlay onto the node? So to do that, I am going to add this overlay as a runtime overlay on the default node profile. So to do that, we are going to do set, and then I'm going to add fake root. So I'm going to run this Warewulf control profile set command, which will set the runtime overlays of the default profile to generic and Apptainer fake root. So to do that, it'll ask me to confirm yes. So I also want to show you, you can also see what runtime overlays your compute nodes are pulling by running the Warewulf node status command. And as you can see, HPC lab compute node 0 is pulling a runtime overlay, which just contains this generic overlay. So after I've set this overlay, runtime overlay on the profile, I can quickly rebuild that overlay for my compute nodes. And we can, and because this is part of a runtime overlay, we can actually watch. Oh, okay. So as you can see, because this is a runtime overlay, we can see that this has already been pulled, and on this compute node now, it's pulled the generic and Apptainer fake root overlay. So if we jump back to our test user now, if we do another we just start off another interactive job, and then we can hit it with that fake root command again. And now you can see I no longer have that warning of the sub-UID not being mapped. And I'm not seeing that warning with my user not being in the sub-UID mapping. So I can get out of that and wonder if this will work. So UID, yep. And as you can see, the same file that's on the head node is now consistent with the file that's on my compute node.